Today's going to be pretty short. So I'm just going to go over these slides that we have here. I think there's about 30 slides or so, and that's all as far as lectures concerned today. In fact, actually, the plan is that that's all for lecture for this week. So that way you can spend some more time with the labs and filling in the gaps there, and ask me questions as to if you have any issues with the labs and such, and we'll try to address those and kind of get everybody caught up this week. So that's the plan for this week. There's just one lecture today, and then the rest of the week will be lab time. Next week we'll be starting on authorization and authentication, which deals with getting users logged in and tracking the users, tracking how they're logged in, dealing with passwords, dealing with some of the security aspects of that, and including working with cookies. So that's kind of where we're going next week. But in order to prepare you for those things, as well as to cover some things that we haven't really touched on yet, we need to talk about middleware. So that'll kind of explain some things that we've already done, as well as show you how to do some new things, especially with building a 404 page and a 500 page specifically. But it'll also prepare you for where we're going next week, which middleware is kind of an essential part of doing authorization stuff. Cool?
Yeah, sounds good. I got a question
Yep.
about the test and just in general for this week. I know we haven't done authorization or authentication yet, but regarding the test and being able to log in, that's not like true. You wouldn't be locked out. You could just go around it by just typing in the route. But the purpose of this is just to test our ability to access the database, make sure that the username and password exist, and then it matches, and then it'll proceed forward. But there won't be any customized content or anything, and one would be able to get around it just by typing in something like dashboard. Am I right on that?
Yeah, basically with the stuff right now, you could just type in dashboard and do that. So our goal next week is to fill in those gaps.
Where there be customized things based on what the user. Okay.
Yeah. So then when you go through the login, then you can track their user ID, their username, their email, and use those kind of pieces of information on the website, as well as then not letting them not letting them get to the dashboard until they've logged in. If they go to the dashboard, send them back to the login screen. Or things like, well, maybe you have some admin functionality that shouldn't be accessible to everyone, right? Like maybe you have the ability to add emojis to the database, right? Or edit them, delete them. Those are kind of things that only administrators should have access, not your usual users, maybe. So that's where authentication and authorization fits in, which is next week. Cool?
Cool, thanks.
Okay. So realistically, to get things working for the test, basically just take the variables you need, like what the current user ID is, or whether or not somebody's logged in, make that a global variable for right now. That will be good enough. We'll talk about how to do it better next week. Okay. So let's talk about middleware. So middleware we're going to talk about here is how to write middleware functions that are used to pre-process our requests with Express. Now, middleware is kind of a large topic. Middleware doesn't exist just with Express, just with Node. Pretty much any platform you have for building web applications will at some point have a place where you can inject middleware. ASP.NET has this. Python has this. They're all. I think PHP doesn't have this, but most do. because it becomes a really important thing to kind of do some pre-processing when you get the request before you actually handle the request per se. And part of that means that part of that is just so that you can build code that is reusable instead of having to write the same code a bunch of times for each of your routes. Okay. So if we look at the general network topology, and we've looked at this in a previous lecture, in general, the closest thing to the user is going to be the client, right? That's where the user sits. And when we're talking about the client, that can be a lot of things, right? So it might be your browser. It might be Chrome. It might be Opera. It might be Firefox. It might be Edge. It might be something else. That client could also be Postman. Remember, we tried Postman for testing our REST APIs, right? But really, we can use Postman to test any route. So it functionally works as a client, as a Postman. You may also eventually maybe have an Android app or an iPhone app. Those would potentially need to connect to your web API and your REST API, and those would still be clients. Cool. So the idea of a client is maybe a little bit more broad than just the browser, which is why we often use that term instead of just saying the browser. Questions?
Nope.
Okay. So in general, that client connects to your application server. So your application server is where we're writing the vast majority of the code. That's where all of our back-end code is actually executing, is on the application server. Any front-end code that we execute, such as actually rendering the HTML page, actually displaying the HTML page, applying the CSS, or running any JavaScript that's runs on the browser, such as anything we're using with jQuery or Ajax, all that stuff is running in the client. The application server is where we're doing all the kind of the back-end logic, and that's the one that has direct access to the database. In general, you really, really, really don't want your client to have direct access to the database. It should always be going through the application server for security reasons, and just to make sure your data is good. So once we get to the application server, that application server can, similar to the client, can actually be a lot of different things. So this semester we built all of our application servers using Node, but we could have also built them in ASP.NET, all the different versions. We could have built them in Java using Enterprise Edition. We could have built this in PHP. We could have built this in Ruby, Python using Flask, or a whole host of technologies, right? So some of the stuff that we're talking about here, we're going to talk about it in Express kind of specific terms, but recognize that some of this stuff maybe applies at a broader scope. It may be a different syntax if you go to a different technology such as ASP.NET, but ASP.NET still has middleware. It just looks a little bit different. So in general, the language that we use to talk between the client and the application server is going to be HTTP. So we send HTTP requests, we get HTTP responses back, right? So the two most important parts for any HTTP request is A, the method, and B, what path do you want? What URL are you requesting? Obviously, there's more information in there, but those being kind of the most important pieces that direct where we should route the request. You also remember we started talking about working with the database. So in general, you'll have a database server. That database server might be on the same machine as the application server. More often than not, though, it will be on a different server. So oftentimes the application server and the database server will not be on the same machine. For your development testing area, they are, but that's not always the case. Especially when you want to go deploy it into the internet, you're probably going to find that those are two separate entities. So when we need to then access that database server, that doesn't go over that doesn't go over HTTP, that goes over whatever protocol the database uses. So we're working with MySQL, so basically we send SQL queries and we get back results, right? So generally we send maybe a select statement and we get back basically an array of rows, right?
Yeah.
We could also be doing insert statements or all sorts of things, but in general, that's what we get forward and back. We issue a query and we get results. And the reason I don't say SQL there is because I'm trying to be more general and also include NoSQL. Even if you're working with a NoSQL database, you're still going to issue queries and get results back. It's just that the queries and the results may look different. So that's your kind of overarching topology of the system, right? So you, at a broad scope, you've got clients, you've got application servers, you've got database servers. There's oftentimes other parts that come into play and interact potentially between the client and the application server, and you may have other things in between here. If you're dealing with them being on different machines, you may have different networking pieces that happen in between, but large in part we can think of our applications as with just those three components: client, application server, and database server. Now the question is, where does middleware fit into this? As the name kind of implies, it fits somewhere in the middle, which turns out to be it's part of the application server, is where the middleware sits. And oftentimes, most middleware kind of sits here, at that intersection where we're getting the request and before we maybe deal with it, before we actually render a page or figure out what resource maybe is going to actually be delivered back as the response. This is not a hard and fast rule. There's a lot of different kinds of middleware, a lot of reasons why you might want to use middleware, and a lot of different things they can do. But most middleware is going to fall into this kind of location. Does that make sense?
Yeah.
Where it's kind of processing the request before you actually get to it. Okay. It's still really part of your application server, but it kind of usually comes a little bit before your regular code that you're used to spending most of your time writing. So where middleware fits in Express is actually part of the application server itself. Okay. So anytime you get a request, it first is going to come to the HTTP object, which is a module that's built into Node. So you've got the Node HTTP model, and you remember kind of the first example or two that we did, we built a server directly against that HTTP module, right, before we introduced Express, which you can do, right? So the first entry point from the network is to go to that HTTP object. Now, as soon as it gets there, Express is actually kind of hooking to that HTTP object and basically giving us an easier syntax and an easier API to work with that. So the application object, the Express application object, hooks into the HTTP. Anytime there's a request, the application receives it and then passes it on to our code, right? So Express kind of sits here in the middle, taking requests from the HTTP object and then passing them down to our code, which, as it turns out, all the code we write is middleware functions. So we'll talk about writing a bunch of different kinds of middleware functions, but in general, everything we write, even the route handlers that you've already written, like if you say app.get, here's the path and here's the function, right? Remember, we have that function that takes a request and a response object.
Yeah.
Those functions are all middleware functions. They're just, as we'll talk about, those are basically route-specific, route-level middleware functions is what we've basically been writing. So a lot of this stuff will actually seem familiar because it should. So in general, the application object will kind of figure out, okay, here's the route it needs to go to, and therefore it needs to go through these functions. So it always ends up that you basically have you can think of it as an array or a chain of middleware functions that it needs to go through. So the Express will pass it on to whatever that first one in the chain is, whatever one has the highest priority. So we'll pass it on to that middleware function. That function then has the choice of then going one of three directions. It can say, well, okay, I know how to answer this, and immediately send the response. So it can say either res.send, res.json, or res.redirect, saying that here's the result of that response. Go for it, right? Other things you might see in there is send file or other methods. You might use write or end and things in there. But in general, that's one option, is they can send the response, right? So that's the one that we've taken the most, right? Or I think render I should put on there as well. If you're saying res.render, that's kind of the end of that middleware chain. With me?
Yeah.
So once you send a response, you're done with the chain. What were you saying? Somebody was chiming in. Okay, so that's generally where the chain will end most of the time. Another option that you have is you can say, well, I have this chain of middleware, so maybe I want to do some logic, but I don't want to send the response yet. And this is where the kind of middleware comes in that we're going to mainly talk about today, is ones that don't necessarily send a response, they just pass it on to the next thing in the chain. So it may run some logic, it can have whatever logic in it wants to, and then when it's finally done, it's ready for the next thing to occur. You just call next with no parameters. Okay, so next with no parameters will pass it on to the next thing in the chain, the next middleware function. Okay. You may also, the other thing that can happen, if there's an error, then it can call next with an error object. And this then means that, hey, something went wrong. I don't necessarily know how to deal with it, so let's go to the common error middleware that's going to be dealt for any errors that we don't know what to do with. We're going to send those over here. So anytime we run a middleware, it's going to have one of those three results. Either everything's good, we send a response, we say, oh, well, just pass it on to the next middleware for further processing. We did some of the processing, pass it on next. Or it's going to do throw an error. And oftentimes middlewares, depending on the circumstances, may run any one of the any one of those three. So you could say, well, if it's bad, right? If you say, well, here I need to be logged in and it's not logged in, well, when maybe I send you off to an error, right? And say, sorry, you have to be logged in. You can't do this, right? So we might send it off the error handler for things like that, or we might say joy. Remember, we put in joy to kind of validate your the data that was sent to the server, right? We might want to come back to the client and say, hey, there's a problem, send it back, right? So you might have errors that way, or the other way you could deal with, say, they're trying to access the dashboard, but they're not supposed to be there, right? I could say, well, let's redirect them back to the login screen. Does that follow?
Yeah.
So if, let's say I'm trying to validate that they are able to log in, I might redirect them to the login screen. I could potentially send them on to the next if they're logged in and all their criteria is right. So it's like, okay, it's good. Or maybe they've given me something that's erroneous. Maybe they have some erroneous information in the request that they made. And then I might send them in an error. So you can have each of those three paths. And that happens for every middleware that you have in this chain. So oftentimes it will go through, your request might go through 3 to 5, maybe more, middleware functions before it even gets to the route handler. Does that make sense? Effectively, your route handler, where you do the actual logic that returns the page, is basically the last middleware function in the line. Does that follow? Because if everything goes good, right? If we know how to answer the query, we don't call next, right? So the last one in this chain is not going to call next because it's finished. Cool?
Yep.
Okay. You'll also notice, so we're sending responses. If it's good here, similar thing typically happens with your error handler here as well. If there's a problem, then it's going to be the one sending the response instead of the middlewares. So if something goes bad, you don't send the response. You pass the error off to. You don't send any sort of response. You pass it off to this middleware, and it deals with sending the actual response back. So what can middlewares do? What can we use them for? We can use them for a lot of things, for a broad variety of different needs and purposes. There's really no limit what you can do with a middleware function. So what I have here on this list are just the most common. This is by no means all of the things you can do. There is no exhaustive list where it's like you can only do these things with a middleware function, because a middleware function is just, it's a function. So I can write any JavaScript code in there that I want to, which really means it could do anything. With me?
Yep.
So common things that we do with our middleware functions, we might parse the body of the request. You can look at the body parser module that's already built into Express to see some of those examples. So for instance, when you post a form, right, we might need to parse the body of that request so that we can actually work with it in our route, right? And so generally that's going to happen in a middleware function that processes the request before we actually get to our route. Right, so that processing needs to happen earlier in the chain, because later in the chain you depend on that request.body property, right? So that's one example. Other things you might do is maybe you have a form where you want to upload a file. There's packages for that. So Multer is one of those. Actually turns out to be really good for working with file uploads. And that's something you inject as a middleware that happens before your actual route logic, is the way that one works out. There's more than one way to use Multer, but that's kind of the most common way to use Multer. You can also use middleware to log all the requests and the responses that your server is generating and is receiving and sending. So Morgan is a really good example of a package that does that. It's really super easy to install Morgan, and then now we can log every request that our servers received. So I can see, hey, I got a GET request on my homepage, or I got a GET request on my CSS file. You can log all those things very easily with Morgan. And I've got a slide later on how to do this. Morgan's actually super easy to set up and use. Jonathan, did you have a question? Okay. Yeah, it linked. I was just curious. It looked like you immediately went to mute. So we can log the requests. That's one very common thing we do. We can also do caching, server-side caching this way. Remember we kind of talked about how, browser-side caching is just by default and it's built in. but that's only for that specific browser. Sometimes you want to cache things on the server so that they're cached for all of your users. So oftentimes you may want to have some, maybe your home page is a little bit dynamic and it's got a lot of data coming from the database. You might want to cache that. Or maybe you have the user's dashboard. There may be data from the dashboard that you want to cache so that you can reuse it and maybe not hit the database every time. So caching is another thing we can do with middleware. There's a lot of different packages to do that. One of the packages out there on NPM is something called memory cache, which will cache data in memory, and it basically works as like a key value pair where kind of you got a dictionary where you say, here's the name of the value, and here I'm going to put the value in, and then you can ask for it later in a later request. And then there's an article here that I've linked on Medium that you can kind of read about how to do that if you're interested in seeing how you might do server-side caching. And it works as a middleware. There's a lot of ways to implement this caching. This is one way. A lot of people end up using Redis cache here because it's a little bit more advanced. We can also do authentication, which we'll talk about next week, which is where we check the login status or their tokens to make sure that, hey, to go to this page, you have to be logged in. So let me check that. And then if you are, then I will do things like update on the request object. I'll add a property request.user. So all the requests later in the chain can deal with that request user object. They don't have to go check if the user is logged in. They can just look at those properties on the user. So that can mean that you can avoid rewriting a lot of code that otherwise you would have to write again and again and again for every route that needs to check that the user is logged in, which, as it turns out, for a lot of websites turns to be most of them. Right? Most websites, a good portion of the pages, you have to actually be logged in to do much of anything. Does that make sense?
Yeah.
So by moving that into a middleware, it means that you can reuse it rather than writing it in every single page. We can also use it for authorization, which means to check that they have the appropriate permission or role. So just because they're logged in doesn't mean that they necessarily have permission to do the thing. So when we deal with things tomorrow, deal with things next week, we'll have authentication. We'll have an authentication middleware, but we'll also have an authorization middleware to check that they have permissions. And that second middleware for authorization, well, it's probably going to pull some data from that user object that was put on there in the first one, in the authentication. So those kind of work in tandem. Another thing that you can do with the middlewares is you can provide some central error handling behavior, so you don't have to write that into every catch statement that you have in your entire application. Right? So I can say try catch, and then, well, if something goes wrong, well, we'll just call next error. Right? You saw you saw that kind of on the diagram that we saw on a previous slide, the error handling middleware.
Yeah.
So we can use that as a central place to have logic that we reuse, error handling logic that we reuse, rather than having to write that for again and again and again. Now, error handling is a little bit weird. This one, that error handling middleware is not like any of the other middlewares. It's different, and we'll talk about that later in the lecture, as there are some just differences to how you have to set that up. But the rest of these are all kind of start the same way. So, in general, if you're writing a middleware function will always have this signature. It's going to take as the first argument, it takes the request object, the response object, and then next, which is the next, basically a way to call the next middleware function. That third parameter next is optional. If you're not going to use it, you don't have to include it. But obviously, if you need to call the next middleware, then it needs to be in your arguments. Paul, you had a question?
Yeah, it was about that. You just addressed it. You don't really need to have it. What is it called if you just have request and response in there? It's not
It's
middleware then?
it's
It
still
just
middleware.
without.
It's still a middleware function. If it's request and response, it's still a middleware function. Although that usually means most of the ones that are that or just have those first two parameters. In general, what I would call them is a route handler is the other name that we deal with them. Because if you're not calling next, well, that means it's the last one in the chain, right? That there's no middleware is going to be after it.
Yeah, or there's no possibility of an error. It's just as simple as, say, sending
Right.
something.
Yeah.
It's always going to
So
work.
yeah, if it can't fail and there's not another middleware ever in the chain, then you don't have to include next. So you always have to have the request and the response, but you don't necessarily have to have next. But to make truly the middlewares that are in the middle, right, the middlewares that happen before your route handlers, all of those will need to do something with the next, because otherwise, well, they'll stop the chain and it'll never go to the next thing, and you'll have your browser just constantly spinning, waiting for a response, which it will never get. Does that follow? So, large in part, most of the examples, with the exception of one, all of those will have this next parameter. So, looking at the Express documentation itself, they've got an article a guide called "Writing Middleware for Use in Express Apps," and this is kind of their take on this. Middleware functions are functions that have access to the request and the response object and the next function in the application's request response lifecycle. So remember, we kind of looked at what that request response lifecycle is. You get a request, you handle it somehow, you send it back with the response. The next function invokes the next middleware, or as you saw, if you pass in an error, it actually jumps and passes on to the error middleware handler instead of the next one. Middleware functions can perform a broad variety of tasks, including they can execute any code that you want to execute because they're functions. They can make any changes that you want, make any changes to the request, the response objects, including adding additional properties to the request, which is really a common thing to do. You may say, for instance, like we were talking with authentication, you might add a user variable, or you might add like a is logged in variable, things like that. Or Multer adds some additional properties to the request object to allow you to upload files. So I believe it's named Files is the one. Correct me if I'm wrong, Mo. Files is the one I think we got added, that got added there with Multer.
Me?
Yep. When we were using Multer, it was Files, right? Request.files.
No, uploads.
Huh?
Uploads.
Request.uploads?
No. Oh, okay. I was confused on what you meant. I have my project open right here, actually.
Yeah. It's not a big deal, but if I remember right, it's the files property. So there's not normally a files property on the request, but Multer adds that so you can know what files were actually uploaded. And then the last thing that they can do in there, last two things, they can potentially end the request response cycle. There's no way to do that explicitly. You just end the function. If the function ends without calling next, then the request response cycle is done. If you call next, then we'll go to the next one in the stack. And that's what the next sentence there kind of says. If the current middleware function doesn't end the request response cycle, and typically that means it's going to send a response or redirect the user somewhere else, it really should call next to let the next thing go.
Yeah, Mr. Smith, it was request.file.
Oh, request.file. Okay. Yeah. So otherwise, if you don't call next or you don't send response back, then the browser would just be left there hanging, waiting for a response, but never getting it. So, they've got an example here kind of diagramming how this might look. And one of the things you should note is this also actually just looks like a response route handler, right? So I say app.get / so that would be the home page. So if I request the home page, then run this function. Well, this function is inherently a middleware function. The ones we've written so far have been more like what we would call a route handler, but I could inject a middleware function this way. And so this function runs anytime I request the home page, and it gets the request, it gets the response, it gets the next, and here it's not doing anything, it's just saying, we'll call next, just run the next handler. So typically I might have something in there to say actually generate the home page, because this has not generated the home page. Okay, so we're saying what path does this middleware apply to? So this middleware applies to the home page route. You will mention you will notice that they say, well, this is called res and rec by default. It doesn't have to be called that. None of the three parameters have to be called rec, res, or next, but that's kind of the standard, so you can read the code. What were you saying, Paul?
Yeah, okay. Is the order important with rec, res, next? And with the next there, what is that doing? Is it for some other function that hasn't been written yet?
Correct. So yes, the order is important. They have to be in that order. You cannot change the order because the Express will always pass it to you in that object, in that order. So if I were to, for instance, switch res and rec, the request and the response, I would, in my code, I would end up finding that the res is the request and the response is the request is the response. They would be swapped because it always passes them in that order. Okay, and what you're asking as well is that next pointing to a function that doesn't exist. That is correct. So next is calling a function that has yet to be written in this code example.
Okay, well, when we've been writing these, though, I don't think we've been using next each time, have we?
Mm-hmm.
Or maybe I got to look a little bit closer now that I have this information, but I don't recall putting next at the bottom.
Because you typically don't in the last handler. In the last middleware, which we call the route handler, you don't call next. So,
okay.
Because you remember your functions end with calling, for instance, res.render, right? Res.render renders a handlebars view. That's the end of the response. So you don't need to call next after that. Or if you look at your APIs, we said, or REST APIs, we said res.json at the end to send JSON data back, right? That's the end of it, so we don't call next. Does that follow?
Yeah, sure. Hopefully we can look at examples to drive it home, because seeing this on here, I mean, I get it, but seeing it in practice, that's where it really gets...
Most of the time, most of your handlers in dealing with your routes, they won't call next. Most of the time you don't call next. The reason you call next is if you're actually writing a middleware that happens before your route executes. Does that make sense? So this allows us to write code that's happening before we actually render the home page.
Okay, yeah, I get it. There wouldn't be much need to do anything after that. Maybe to refresh the page if it's being updated, like it's a stock tick, something like that.
No, you wouldn't. The sending the response is what finishes the refresh. The refresh is already started when you're issuing the request, that's kind of the beginning of request. That's, if you refresh the page in the browser, that starts a request, and what finishes that request, what finishes that refresh, is sending the response back. So all this code is running in between when you started the refresh and when you finish the refresh.
Oh, okay. So an example of, say, like a stock ticker that's more or less real time, then something else would initiate that process. But this process in itself ends with rendering the page.
Yes, this page ends specifically with rendering the page. Dealing with something that's continuously rolling is a whole different story, and that's where you get into something called WebSockets is a common solution for that. But that's a completely different topic. If you're doing WebSockets, you're not even going through Express. So what is this next method? And this is I pulled this diagram from another article, which I don't think it's not on Medium and it's not on the Express page itself, but they had a decent kind of explanation of what this next is and where it fits in. So in general, you can kind of think about it as your request comes in, your response goes out, but in the interim, you may go through a series of middlewares. So in this diagram, we've got 5 middlewares that it's going through. The last one is what actually sends the response. All the others in between, these just call next, do some processing next, do some processing next, do some processing next. They're just doing some processing on the request before we are ready to send the response. Okay, so the reason we haven't used next is because we've only been really writing this last circle. We haven't written any of the circles in between, which is the ones we really call middleware. Okay, so generally this one at the end we refer to as the route handler, and the rest of these is what we call middleware functions. Cool?
Yep.
But there tends to be a little bit of confusion because, well, they all look like middleware. So even if you look at the Express documentation, they call this last function a middleware function as well. So in general, a middleware function is basically a function that will receive the request and response objects just like your route handlers do, route handlers being the last one in the chain. As a third argument, you have another function, which you should call once your middleware code has completed. And this means you can do things like wait for asynchronous calls, whether it be with the database or network, or if you need access files, you can wait to call, you should, and you can wait to call next until those complete. So for instance, maybe you need to get some information about the user, so you might make a request to the database, get the user information before passing that on. And so that might look like the diagram on the right is what this is saying. If the current middleware function does not end the request response cycle, you need to make sure that it calls next to pass control to the next middleware function. Otherwise, it'd be left hanging. So for instance, if this third one in the middle, right, if it didn't call next, we would never get to the one at the end, which means the user would never get a response. If this one doesn't call next, then you don't get a response. Does that make sense? So if it's not the last one, it needs to call next. If it's the last one, then it's not going to call next. Cool?
Yep.
So we've kind of talked about what middleware is. It's a function, and we talked about the signature of it. Want to kind of we're kind of drilling down to start how you install it, how do you use it with Express. So when you use middleware with Express, there's actually 3 different levels that you can install it at, which means that the syntax is a little bit different depending on where you install it. Not much, but just a little bit different. So we can install middleware at the application level. Application level means that it's used for every route in our application. Okay. From once we install it, every request that gets to there will go through that middleware. Okay. So we install it broadly at the application level, and that's one of the common ways to do that. That's what we've already done, actually, is showing you how to install middleware at the application level. You can also have her install middleware at the router level. So say you only want your products API, right? Maybe you only want to install some middleware in that router, right? That maybe that doesn't make sense to install that middleware globally, right? Because it's not something you want to handle every request with. So that could be things like maybe at the router level, I want to say, well, let's take the things that we have this module, right, which contains several routes. For all of those, you have to be logged in, right? I might install that at the router level, and that way I don't have to specify for each route that you need to be logged in for that route. Cool? So installing at the router level does everything for this router, and the next level, the lowest level, is we can install it at the route level for just a specific route. Okay, so we can install the application for all routes, the router for just the routes in that router, or the route for a specific route. Questions?
Is it going to be like situational, depending on like what one we use, or is there like one that you prefer we use?
No, it's very much situational. It depends on, how broad should it be. So that really depends on what the middleware needs to do.
All right.
What would be an example of something you wouldn't want at the highest level like we've been doing?
At the highest level? So things that we often find at the highest level would be things like logging. Okay. Things that you don't find ever at the application level are things like caching. So if you want to say maybe save cache a specific response, you don't want to pry that largely because you wouldn't want to say, for instance, let's cache post requests, right? That would be a problem. So things that we make as post, put, delete, those methods, we never want to cache those, large in part. So those are, does that make sense?
Yeah.
Other things might be like, we're going to talk about authentication. Oftentimes on your website, there's pages where you can go without being logged in, right? For instance, your home page, right? So if I install that middleware across the entire application, then you can't even get to the login screen without being logged in. Does that follow?
Yeah. Okay. How do you initiate middleware at a router or route level? I mean, what line does that come down to? We're not requiring Express. I mean, that's not what it is, right? It's something different.
It's something different. So I've got 3 examples here, and we'll go through them.
Okay, brilliant. Thanks.
Yeah. So these 3 examples are going to be, I'm going to use a very simple middleware. The middleware, all it's going to do is going to log that we received the request and go on to the next. So the middleware I'm defining here, I'm defining this const logger. So this is my logger middleware. So it's a function that takes the request object, the response object, and the next. And then the logic in here is just 2 lines. First thing we log, then we call next. That's my middleware. Okay, and if you look at what this log is doing, there's a template string there. You can see with the graves at the beginning and the end. What I'm doing is I'm logging the method that we received, the URL that was requested, and then also the current date and time. So this would log, for instance, that it was a GET request to the home page at 3:30, right? So this is my middleware function. Any questions on that? So your middleware can be really simple. It can be sometimes oftentimes they're a bit more complicated than this, but that's the gist of it. You know, it's just a function that does some stuff and then calls next. So the way I install this application level is I just say app.use and I pass in the logger function. That's it. And I could have done this at one line. The reason I'm doing it on two is just to clarify and see that, you know, this is oftentimes how you're going to see it, is not necessarily one line, but it can be one line. Cool?
Yep.
So to install at the application level, you just say app.use. You'll remember we've already used app.use in a few different places in your application. Where have we used that already? App.use.
Static files.
So static, right? Which that means that Express.static is a
Middleware.
It is a middleware. Okay. So it's a middleware that we've actually already used. What about some other ones? Where else have we used app.use? I can think of at least two other places.
When we require something like Bootswatch or Bootstrap.
Those
are static pages.
That's still static. Yeah, that's still the static example.
Requiring the APIs.
The APIs? Okay. So if I'm bringing in the APIs, what am I bringing in? Do you remember that there's something I had to do to set up those API modules? What did we export in the API modules?
A router object.
Router object. So if I'm using that, if I'm saying app.use, I'm bringing in the router. Which, as it turns out, so the router is also a middleware. That's how it's implemented. Part of it, at least.
You mean within the APIs themselves, where you require the router?
Yeah, we say we require Express, create the router, and then at the end we export it, right? So when we're saying app.use, we're really bringing in that router object. That's what we're using as our middleware. What's another one? Remember we had to do something with app.use anytime we work with forms.
URL encoded.
URL encoded, right? So URL encoded would be another middleware, right? So we've kind of we've dabbled in this a little bit, but we maybe haven't gone into the details yet because you didn't necessarily need to know all the nitty gritty yet.
So basically, app.use, that means middleware is being used.
Yep. Basically, large in part, is that you're installing a middleware. So you're installing a middleware that will happen at that point, and it's going to, if you use app.use, it's saying that it's being basic, it's typically being put in there and installed for every route. So regardless of what method you're sending the request with, or regardless of what the actual URL that you're requesting, the path that you're requesting, that middleware is installed and operating.
Okay, and it's you don't use it for post, but you would use it for get, right?
We use middleware for both. It just depends on what kind of middleware you're using.
I thought we weren't supposed to use it for post or with puts or something.
I was saying about caching. Caching
right.
middleware, specific kind of middleware. So that doesn't apply to all kinds of middleware. So app.use is for everything. That would include the gets, the puts, the etc. You can also install it at a router level. Router level is really easy. You, instead of doing app.use, you do router.use. So router.use covers all of the everything that goes to that router. Cool. Now, this is one of those cases where, you remember we kind of prefixed when I installed the router, right? If I didn't prefix that route, so I didn't say, well, this is only the API, if I didn't say this is only for like API product, well, then effectively any of the middlewares that I install at the router level would be installed at the application level. Does that follow?
Yeah.
If you mount the router at the root, then all of the middlewares that you install in the router is really mounted at the root as well, which means that it applies broadly. So the place where we use this, installing in the router level really relies on you having used a prefix in the first place back in server.js. To say that this router is only applies to routes that start with X. Otherwise, you're installing the middleware in the router, you're still installing it globally, which is not generally the purpose of installing middleware in the router. Okay. And then the last way that you can install middleware is on the route level. And the way you install middleware in the route is actually really, really simple. So here I have a route for get the hello route, and you see I have my route handler after it. Notice that I've got this word logger in the middle. Do you see that? So here I'm injecting this logger middleware, but I'm only injecting it for this one route. It doesn't apply to any other routes. With me?
Yeah.
Yeah.
So that's how you install it at the route level. Is you put it into the .get, the post, the put, the delete, and you say run this before I run the handler. Now you have to make sure that you put these in the right order, right? Because basically if you switch this, right, we say rather than putting logger before our route handler, we put it after. Well, then it would never be called because this method doesn't call next. See that? It only works because it's called before the route handler. So to summarize in terms of installing middleware, if you want to install it at the application level across every route, you use app.use. If you want to install it just to a specific router, you say router.use. Or if you want to install it in a particular method, particular route, you're going to put it into that get, post, put, or delete method as the second parameter. And you can actually put more than one. You can put more than one middleware using this method. You can actually put as many middlewares as you want. So if I want to put 3 middlewares there, I put middleware, comma, middleware, comma, middleware, comma, middleware. I can put as many middlewares in between here as I need. I'm not limited to just one. Cool?
Yep.
So, for instance, I might do things like, if I wanted to install the URL encoded middleware, right? I could install that in any of these 3 levels, right? It doesn't have to be the application level. If I install it in the application level, well, then I don't need to bring in URL encoded anywhere else, right? But maybe I don't want to bear that burden for every route because maybe not all routes have forms, right? So I only need to inject that in routes that actually have forms. So I might say, well, let's not put URL encoded at the application level. Maybe I just put it on the route level wherever I need it. Does that make sense?
Yep.
The catch there is, hey, that does end up making your server faster because it's not running it when it doesn't need to. But it also means that you have to then copy paste. You have to put that URL encoded multiple times throughout your code, which means some code duplication, right? So oftentimes we may put it at a higher application level, A, because we actually need to capture every request, or B, just to avoid code duplication. Similarly with router.use, we may put it at that rather than the route level specifically to avoid code duplication. So we looked at how to write a middleware function, right? So I had that logger middleware function. Oftentimes I may want to reuse my middleware. Maybe I want to reuse it in a bunch of different modules. In order to do that, oftentimes we'll create a middleware module, which is actually pretty easy. So here I'm moving the code into a file middleware in the middleware folder, call it logger.js. So I define my middleware function and then I export it. Say module.exports equals logger. That's the middleware module. Simple as that. Questions?
Nope.
So I break this out, and then if I want to then use that anywhere in my code, I can say let's require middleware.logger and just integrate it in any of those three routes. So I can integrate it at the application level, I can integrate it at the router level, or just on a specific route. So breaking these middlewares up into separate modules is actually super easy. So oftentimes we'll do that because most middleware, it's not necessarily true of all middleware, but most middleware you'll find that you need to use it in more than one place. Especially when we talk about dealing with users and authentication and authorization. Those are things that we're going to use across the application. We really don't want to rewrite that every time we need it. So we'll break it off into a module. So let's talk about some kind of specific specialized middlewares. And the two I want to talk about now are going to be about how to build a 404 page, 404 error page, and how to build a 500 error page. So remember, a 404 is anytime that your server can't find the thing that was asked for. So for instance, maybe you're asking for /test, but there is no /test. You might want to install a middleware to say, here's the 404 page that I want you to generate. And the way you do this, if you say app.use, we put this after all of our route handlers. As it turns out, this will then get called if there's nothing else, if there's no route handler that's handled this route, then this will end up getting called.
So it would make sense to put this in that middleware folder because it's so broad.
This is so broad, but it turns out you only ever need to write this once. So you could put it in there for the 404 page, but it really doesn't have to because it's only ever going to be once in your server.js. Does that follow?
Okay. Yeah.
So this 404 you only ever install once, and it's going to be after all of your other routes. So towards the end of the file, usually this is right before you call listen. So we're going to say, okay, well, let's log. I'm just going to say console.log, page not found. And then I'm going to send back the response. I'm going to say status 404. This is type text plain, and it's going to come back as page not found. So that's a really simple version of a 404 page, right? No fancy HTML. It just says, hey, the page isn't found. Right? But it sends it back as status 404, which is helpful for instance, if we're doing Ajax, then this will come back with the 404 status instead of like a 200 status. Oftentimes, you've probably seen if you had the wrong route to maybe your CSS file, your Bootstrap CSS file. You remember, I think Corey, you had this problem when you were kind of messing around with it last week? Do you remember running into that? Maybe your route to your CSS was wrong, and it said, well, I got HTML instead of getting CSS. Well, that's because the built-in, basically 404 page doesn't send the right status. The built-in 404 page sends status 200, which tells the browser that everything's good, instead of sending a 404 status. So this changes it to make sure it sends the right status when the page isn't found. So that, just installing that will give you better, just having that status 404 will give you better feedback, anytime you're doing Ajax or looking at the console log in your browser. So that's a simple version of the 404. Let's look at a simple version of the 500 error page. Now, there's a very special kind of middleware. We talked about the error middleware, error handling middleware. In order to define that, the error handling middleware has a very specific signature. It needs to take exactly 4 parameters. If it takes any more than 4 parameters or any less, then it won't be treated as a error handling middleware. It will be effectively kind of ignored and treated as a regular middleware. Cool?
Yep.
So the 4 parameters it needs to take are the error. Error has to be first. Error, the request, the response, and next. So if you're defining an error handling middleware, it needs to have that syntax, no other syntax. And you'll notice that I've added the comment here, ESLint, disable next line, no unused vars. Because normally ESLint will say, hey, there's a variable on the next line, you're not using it. And so if you then remove one of those, you say, well, I'm not using it, I'll remove that. It turns out that this breaks. So that's why I'm giving I'm disabling that error message here so the ESLint doesn't complain that maybe, hey, I'm not calling next. You should remove next because you would break it. So the first parameter has to be the error. First parameter has to be the error. Normally, remember all these others, it was request, response, and next, with next being optional. For the error handler, you need all 4. Cool?
Yep.
So in there, then you can, this is where things go when you say next error. If I, in my catch, remember how we said next error and passed in the error from the catch? This is where it goes. So I define this generally in the server.js, and I'm going to define this all the way kind of at the end usually. In fact, I'll define this after the 404 one route that we just defined, which I said is usually the last one. Well, this one's usually after that. So I say that, well, let's log error.stack, which is a stack trace of everything that's happened. So that gives us some debugging info. And then I'm going to send back a response. So here I'm saying res status 500. Status 500 says that there was an error on the server that we didn't handle, which in general is what it's going to be when you get in here. Sometimes the thing you can do is if you want that to be a status that's different, you might say request.status equals 404 or 400, 400, and you might then use that here instead, for instance. But oftentimes this will be a 500 error.
Hey, Mr. Smith,
Yep.
I got a question. So
Yep.
the second line with console error, that tells you in detail as a developer what you need to go to do to fix.
Yes.
So you don't display that on the page because the user just doesn't need to see that. Otherwise, you could just do that, right? You could just send the error.stack instead of unhandled service error.
I could. The problem is the error.stack is, I believe, an array or an object. I have to turn it into a string to send it back. Does that make sense?
Okay, but if it's in the console, we can read inside of it.
Yeah, it's in the console, so you can read it. And that's on the server console. So I might say, when I send the response back, you remember the previous one, I sent a status code of 404. Here I'm going to set a status of 500. Say I'm just sending back plain text, and here's my string. So unhandled server error, that's what you would actually see in the browser. Okay. And again, this is with no styling. This is kind of your bare bones simple version of both the 404 page and the 500 page. Does anybody have questions about those two? The 404 page or the 500 page? Okay, I'll take that as a no. So looking at both of these, my next question is, how can I make these better, right? So I've got the 404 page. What could I do, for instance, to make this a little bit better? Should I be using console.log?
No.
Probably not. What should I use instead?
Probably debug.
Probably debug. Yep, debug would be a better choice than console log. Same thing with the other one, right? I probably want to use debug to log the error message. What else? Does this error message tell me what you were trying to ask for?
No.
No. So I probably want to somehow include there both the method and the URL that you were asking for, right? So maybe I want to say that you were trying to post to /test, right? So I might want to include those in the error message. What about this? This is coming back as a plain text response. That's not going to look very good to the user, right? And so if they go to that, that's literally all they're going to see, and is just a white page with the text page not found. They're not going to see things like their nav bar, your nav bar for your website, right? I probably want to see it, in HTML in kind of the context of your page. So what would be a better thing to do here?
Make an error page and then send that instead.
Yeah, make an error page and send that and use that instead. So how would I use that instead? What would I say instead of send and type?
Res.render and then
Say render, right? So what I would say is actually res.status404, because I still want it to be status404, and then I'd say .render. So res status render is the way I would do this. Okay. So let's look at how I kind of put that together. So it improved the 404 page. I might say debug here, and I've got a template string. You can see that with the graves. So I'm saying request.method. Request.method gives me the method that was the request was issued with. So for instance, that would log as get or post or put or delete. And then original URL gives me the URL that the full path to where they posted it to. I don't use URL here because URL property kind of gets changed as you're processing it with routers and sub applications. So original URL gives us back to the original thing that they actually requested. So this will now log if I go for post to /test. This would say post /test not found. So that gives me a more useful error message in the console back in VS Code. So I can see, okay, this is what happened and what you're trying to get to. That helps a lot. And then I'm saying res status 404 because I still want it to come back as a 404 status, not as a 200 status, which would be normally what it is. But since this is actually a problem, I want to send back that 404 to say the page isn't found. And then I render. So here I'm saying I want to render the error view. You might have a different path to that. So for instance, if you're putting it in the error folder with, I think if you look at the Cowboy Boots example, I put it into the error folder and called it basic. So in that case, it was error/basic is the view I'm rendering here. If it's just back in the root, well, this would be just the error.handlebars. So I'm rendering the error. I'm passing in a little bit of data to kind of display on that page. So I've got my title. Title is page not found. my messages, we could not find the page requested. So I could build a view to show those two pieces of information. Does that follow?
Yep.
You can see how that might be a better user experience, right?
Yeah.
That would go above the 500 page, right?
Yeah, this would go back the same place. It would go before, generally towards the end of server.js, but before your 500. Okay. So similar note, I can improve the error page as well. I might say instead of doing console.error, I might say debug and write it to debug and say error.stack. And then when I want to render a view, I still want to give it that status 500, but I would render the error view because it turns out I can, basically these are the same thing. I can use the same view for my 404 page and my 500 error page. So I'm going to pass in the title of that page as error. The message is error.message, which I'm pulling off of that message object. And then if I wanted to show the stack on that page, I can add in error.stack, and so that would give me all the information if for some reason I do want to show the stack on the front end. Does that follow?
Yep.
So any questions on that 404 500? Okay. So that's how you build a 404. Let's talk about Morgan. Talk about, a common thing I want to do is oftentimes log all the requests that are made, so I can see what are users asking for and when did they ask for. And this can be really helpful, especially when you're trying to debug. Hey, I've got this error message that I've this big stack trace that I saw in my log, but what caused it? Well, if you put in Morgan, then you have a log that says, well, they were asking for this file at that time. So that really, really helps with debugging a lot of issues, having a log of all the files that were requested. And installing Morgan is so easy. You just have to say, well, let's install the npm package, npm I or npm install Morgan. Okay. You require it. You say const Morgan require Morgan. And then when you want to install it, well, Morgan's a really good thing to install application-wide because we just want to log every request that we get. If you wanted to, put it at a lower level and maybe not log every request, you could do that with a route level or router level sort of install. But here I'm going to usually install this application-wide. I would say app.use Morgan, and then I'm passing in tiny. Morgan's got a few different formats that you can have the logs come out as. I usually find tiny is generally good enough. Is generally what I want for most things. But you can look at the documentation to see what some of the other options are for Morgan. But that's typically all you need. 3 steps. Now all of your requests are being logged. So if I look at, for instance, the Cowboy Boots example, we can kind of see I've already got Morgan installed. And so I've brought it in on line 10 here. Actually, I should share my screen. Change windows so you can see this. So on line 10, I'm bringing in Morgan. I've already installed the npm package, and then down on line 36 here, you can see the app.use Morgan tiny. That's how I install it. So now every request, every time the user asks for a resource, you're going to see it in the log. So if I go to the browser, for instance, now with Morgan there, I can see if I go for the home page, everything happened kind of quickly, so I might not be able to see just from the browser what it actually asked for, but look at what actually happened. So we saw that we went to, and this is what Morgan's logging is all this stuff here. You see the first request was a get to the homepage for /. See that?
Yeah.
So, and it says the status code that returned was 302, which means it was a redirect. So it came back and told the browser to go somewhere else, which is what I've kind of set up the homepage for. And you can kind of see the placeholder here because I don't have a homepage. I'm just telling it to redirect the user to the /product. So that's where you see this comes back with the 302 request, and then it immediately goes and requests /product. Okay, and you also kind of see how long it took to render each of those pages. So this took 3 milliseconds to render that. It took 106 milliseconds to render the actual product list. And then we went to Bootstrap min CSS. It asked for CSS main. It asked for jQuery. It asked for Bootstrap. It asked for main.js. So you can see all of that is just coming from that one line where I installed Morgan. Cool.
Cool.
So that gives you, there's a lot of reasons why you might want that, and pretty much any application benefits from having Morgan, because for one, it gives you a better way to diagnose problems. So for instance, if there was a 404 error, if it was trying to get something and that failed, I would see that here as the status code. But it also means that I can potentially, let's say I posted this, I've got this up on, where did we host this stuff? Up on Heroku. I can look at the logs and I can see on Heroku, well, they asked for this, they got a 404 error, or I can take those logs together and kind of see, well, these pages are being visited the most often, and oh, well, it looks like sometimes my product list is taking 2 seconds to load, right? Maybe I need to look at the performance for it. See that?
Yeah.
So that can be really, really helpful for diagnosing errors in production and seeing, well, what are those pages that are really slow, because I can look at the logs and see what's going on. So that's a really, really, really helpful tool, and it's so easy to install.
And it's just that one line?
It's just that one line. Really, that's the important line. The rest is, install it, require it. That's it. You've got Morgan. The catch is you want to make sure that happens early, right? So you'll notice in the code example, you see where I have it. I have it before I get to any of my routes. If you put it down later, it's going to miss all the routes that come before it. Does that make sense? So if I put it after the home page here, for instance, that would not be in the logs. So things like that, oftentimes I don't want my favicon to be in my logs. So, and that's where I've got this serve favicon module. I'm installing it before I bring in Morgan, because I don't want the favicon stuff to be logged. Cool.
If you use it and let's say you just want to temporarily disable it, you can just comment out 36. It won't break anything.
Yep, nothing broken.
Oh,
Logs
good.
turned off,
Okay.
nothing broken. Yeah, so that's another reason that's just like, oh, I don't have to go change the entire application. I just comment out one line and it's turned off. So, if for whatever reason I'd only want to have that in development or only want to have that in production, I could put a check in here and say, well, if it's production or if it's development, then install it, and otherwise don't. Right? So I could easily put an if statement around that and say only do this in production or only do this in development. Cool. So that's a really common middleware that we'll use, and I would ask that you get install that with all of your applications going forward, because it will just make them better. The next thing to look at is there's a there are some built-in modules with Express, which we kind of already talked about. The big three middleware functions that are already built into Express being static, URL encoded, and JSON. So static, as we saw, is used to serve all sorts of static files, HTML, CSS files, images, etc. URL encoded is used to parse incoming URL encoded payloads. Those are things like forum posts, but there are also other things that may sometimes come in as URL encoded. But generally, that's forms. The next thing you have is the Express.json, and that's used to handle anything that's coming in as a JSON payload instead. So both URL encoded and JSON body results in that request.body attribute being there. Oftentimes you may get JSON posts from payloads from things like Ajax or Fetch. Also, oftentimes if you're writing a mobile app, say an Android app, you may be sending JSON data to the server instead of submitting a form. So having that Express.json middleware in there means that you can handle those from mobile apps. So installing, using those middlewares, we've kind of already worked with them, but just a refresher, you're going to say app.use, express static, and then you just tell it which folder you want to pull the file and serve the files from. So this would serve everything in public out there. To use URL encoded, I'm going to put that up earlier. And I could, here I'm doing this application wide, I could do this router wide, I could also do it in here just on the route level. But once I do that, that's where we get this request.body object, which is what we're using to see what the user posted in the form. Cool? So if you ever see request.body coming out null, that probably means that you haven't installed your middleware for parsing the body. Cool. It may also, there's other things that can go on. It may be not installed. It may be that your content type is wrong as well in the request if you're using Ajax.
Didn't we use request.body with a form?
Mm-hmm. Yep.
Okay.
Yep.
And that goes into the URL, which that other line, the express URL encoded, that pulls that apart.
Mm-hmm. Yep. So it goes into as part of the body of the request. If you're sending a post request, that comes in as the body of the request. If you're sending it as a GET request, it goes in as the query parameters. But both of those things are typically, whether it's a GET request or a POST request, oftentimes that is URL encoded both ways. And that URL encoded basically says that it's kind of taking the special characters out and replacing them with special syntaxes like slash. Remember, %20 represents a space oftentimes. Right.
Okay. Or we call body encoded or something a little easier.
Yeah.
I don't like the two necessarily.
Yeah. But that's the name it is. I don't have any control over it. But also, if you to use the JSON one, it's very similarly. You just say app use express JSON, and you can install both of these together. They work just fine in unison. But that also then gives you the request.body, but only if it was sent as a JSON payload. Okay. All right, so you can go ahead and take a break, but the rest of the day is the lab day. I'll post. I'll get this posted up on YouTube so you can rewatch it. But that's the theory for this week. There are some. If you go on to Perusal, you'll see that there are some reading assignments that I've posted out there related to this stuff. I'll also be taking the slides that we just covered now, and I'll be posting those up on Perusal as well.